let's do some visualization of data. Before we proceed, let me just remind you of a couple of commands that are useful once you complete your data set or you bring that data set into Stata. It's a good idea just to check the data on, in general. So there are two commands that do that. One is called describe. These commands allow you to see information, general information about the data set, number of observations, variables, when it was created, the variable names, the type of variable, the storage type for each variable, some of the format that it is, the labels assigned, if there are any. In this case, we have 3 for the merges, and the variable label. So this gives you some an idea of what is in the data. And the summarize, as I showed you before, gives you some basic descriptive statistics. If you don't see anything in that, it means that the variable is in a string format. If you see a number, it's basically give you basic information, observations, mean, standard deviation, the minimum and maximum values. This allows you, one of the things that I suggest you spend some quality time with this table in terms of checking the main variables, the variables that you are very interested on working with, and make sure they are in the expected range, especially the mean and maximum values. So let's say, for example, for these variable cases, you see a minus 9999, right? So that's kind of weird. So we need to go in and check, and maybe there is an error or something. So check this column, these last 2 columns, to see, to make sure that the ranges or the values for each variable that you want to work with are in the expected format. So when we have panel data, the first step you need to do is to actually tell Stata that you have a panel data. And you do that by combining the 2 main variables, the variable that has the panels, and in this case, country. Panels could also be, states or counties or companies, family IDs, etc. In this case, it's country, and the time variable. In this case, is a daily time variable. So the command to tell Stata that we have a panel data, so we can use also the time series operators, which is one thing that we need to use. Is called xtset. So panel set. And then we need to list first the panel variable and second the time variable. So let's run that. And then you can see here we have an error. And Stata tells you that the string variables are not allowed in var list. So if we browse the data, again, because I was in edit, now I'm going to browse. You see day var is fine, it's in day format, but this country is in red, it's in a string format. Stata doesn't like that. So we need to somehow transform this variable into a numeric variable. So that doesn't necessarily mean that Brazil is going to have a number that has some significant meaning. What it means that we need to assign a number to Brazil, we need to assign a number to any or all of the other countries. And Stata has a command for that. It's called encode. So encode, what it does, it assigns, it sorts the variable alphabet, the different levels of the variable alphabetically, and assigns a number in that order. So basically, encode country, there is a comma here because we need an option. Let's generate a new variable, and in this case, just to make it short, to keep it short, let's call it, I'm going to call it country 1. And so let's see, no errors. And let's put them all together at the very beginning. And then let's go to the browse. Now, if you notice here, Brazil, this is country 1, is in blue. Country, the original was in red, it's a string. This is now is a numeric. Brazil now has, this is what you see, but for Stata, this is number 31. So if we go Cyprus, it's number 59. So basically, it orders alphabetically and then assigns. Afghanistan in this case is number 1. So now that we have that, we can actually reuse or rerun the command xtset, but instead of using country, let's use country 1. So we're going to do that here, and then no errors now, and it gives you a report. It tells you, okay, the panel variable is country. Unbalanced means that not all, there are some countries for which you don't have a time series. And then the time variable here is day var from the January 22nd, 2020 to August 31st, 2022, and it's daily. So with this, we can use now time series operators. Let's say if, for example, you instead of having a panel data, you have a time series data set. Let's say just country A observed over many years. Instead of using xtset, you will use tset, and then whatever the time variable is. So now that we have the panel data set, there is a graph that actually can plot all the graphs at once, all the panels at once, and that is called xtline. I'm not going to run it here, mostly because this line, you can try, but this one is going to give you about 200 little tiny graphs that it's going to be hard to see. I mean, this command is really good for when you have a few panels, right? When you have 200 panels or more, or even 100 panels, it's kind of hard to see. There is another one that is for this many graphs might be fun. Is the same xtline cases, comma or det, comma, with the option overlay. What it does is it's going to create what is called the spaghetti graph. Different countries, you're going to see a lot of lines. And make sure to remove the legend. Otherwise, you're going to have like 200 legends in there, 200 names. If you want to see more examples, use xtline. This command is really good when you have very few panels. Not this many, the ones that we have in here. So we are going to explore the data. Using at the beginning with time series, what is called time series graphs. Time series graphs, basically what it does, it plots the variables over time. And the nice thing about those type of graphs is allow us to see trends. We can see whether trends were going up or down. Allow us to see cycles, where the variable goes up and down. Regularly, and in general, we can identify patterns in the data. That's what visualization helps us with. So in Stata, the time series graphs, also or line graphs, on the x-axis, time is always there. On the y-axis, you put whatever the variable you want to explore over time. The command is a two-word command, is two-way line. This is two-way because this type of graphs allow us to add other graphs. So we can combine different graphs into one. So two-way line, that's the command. And then the first one is the variable that you want to put on the y-axis. And the last variable, we can put more variables here. Just make sure that they have the same units. In this case, we're going to just plot these two. Cases over time. So day var is the last variable. So the last variable is always the one that goes on the x-axis. And here we're going to just plot it only for the US, right? So here you can say, even though we have a lot of countries in this data, we only want to plot it for when the country is US. The conditional if allows us to select the country. So I'm going to run this. And that's the graph. So you see it's a very raw format, kind of hard to see if there is no titles or anything. This is the original graph. So in this case, you can see the cumulative cases over time. It's pretty much a 45-degree line. So let's make this graph a little prettier. So whenever you do a visualization, make sure that the graph or the visual that you're trying to create has all the elements necessary for whoever sees the graph can actually understand it, can actually read it, or at least understand what you're trying to show with the graph. So this is the same part of the previous graph, but now notice there are options in here. And if you want to see all the options that you can have with the graphs, you just type L two-way line, and then you can see a lot of, there are many options that you can have. Here I'm going to just show you the basic ones. Obviously we need a title. So there is a title here, and you don't need to put quotes as long as you don't put any weird or commas or any weird characters. If you do or you get errors, just make sure you can put the full title in quotes. And in this case, that's the title of the graph, right? Now, the white label controls how the tick marks looks like, how the values assigned to each tick mark looks like. I'm not going to change the scale. That's what I'm going to put this empty, but it has a comma in here. Basically, the first section before the comma controls the scale, the display of the values, and anything after the comma controls how you see the values. In this case, I'm going to make it a little smaller, and I'm going to format those numbers because these are going to be in the thousands, and I would like to have some commas in there. If you remember the previous graph, there's no commas in there. It looks really the numbers overlap to each other. So what I'm going to do here is I counted the number of digits that the biggest one has, and we have 11 characters, digits and special characters, including the commas. We don't have decimals, and the value is fixed. It's not going to be generic, and what add the commas is the C. And then the y-axis needs a title. This is the y title for the axis, number of cases. The X title is self-explanatory in this case. I'm not going to add anything. That's what I put double quotes. And this line here, it controls how the X-axis labels look like. But in this case, instead of X, we're using a T. And we're using a T because we have a day variable. We have a time variable. If this variable were not time variable, we should replace this T label with an X label. But since we have a T label, what a T label allows us to do is to have a better control over the time. So if you notice in the previous graph, Stata decided where the span of the time or the days. In this case, we are telling Stata, okay, start from the beginning, go all the way to the end by 15 days, right? So here you can control 30 days, 45 days, whatever. If you download a newer version of this data, and let's say you are in October, so make sure you just change this to the last date in your data, and on October 31st, or October 30, or October 21, whatever date you have. Make sure you update this part. So this is the same as the T label, the Y label. So the first shows the scale. After the comma, it shows how it looks, right? So we want to make it smaller, 1.5. You can play around with this. We want it in 45-degree angle, and we want also a grid. So basically vertical lines. So I'm going to run this. This is for cases. Now the graph looks a little better, right? So it has a title. It has a title here. The numbers can actually, you can see the numbers. You know, here immediately you can see it's almost 100 million cases by the end of August, right? And the dates are a little bit more, 15 days each apart. And if you like this graph, you can just right-click, you can copy the graph and paste it in your Word document, or you can save it as a JPEG or a TIFF, and then or a PNG. You can just import it into your Word document. So for the most part, copy is the fastest way, and you can just paste it into your document. So that's the graph for cases. Now let's do for dates. It's the same thing. I copy the code, and then you just put the dates in there. And these are the number of dates, over 1 million. You can see the commas allow us to see it better. So that's for the US. So remember that we assign a number to the country, to the panel variable. So let's see, for example, how those numbers look like. There is a command called label book. So for any variable that has labels or numbers assigned to the categories, label book is a variable to use. In this case, if you see, this is all the list of the countries in alphabetical order, and some information of the type of variable, and it gives you the area. So let's see what the US is here. So it's number 263. So here we can do the same graph, two-way line cases, but instead of using the name of the country, we are going to use the assigned number. In this case, it's 263, and this produces the same graph as we did. So the same thing. Now, notice in this case I play around also with the titles. I put a bold in cumulative and italics in the United States. So this is in here. So in curly brackets, you can say boldface, cumulative, whatever you want to convert, change, and then italics in the name of the country. Right? So here, if you want to see more about this, here are some links. And one thing that I also mentioned when we started the visualization is if you want to see some examples of different graphs that you want to try in your work, there is a gallery of graph for graphics for Stata. What you do is you just select the graph you want, copy the code, and adapt it to your own data. So let's say, for example, you wanna compare two countries. Right? So the two-way option allows us to add another line. So these two parallel bars means that it tells Stata that another graph is coming. Now this is all Stata. In the newer version of Stata, you can use parentheses. So you, instead of the parallel lines, you can use parentheses. I personally like the two parallel bars, mostly because when you add parentheses to a lot of options that already have parentheses, it gets a little confusing, but I think it's just a matter of getting used to. So in this case, I'm going to use the old version, but just so you know, in the recent versions, they separate different graphs with parentheses. So here we have the first line. This is the one that we've been using. We have the two parallel lines, and I think one thing that I've been forgetting to mention is these 3 forward slashes. What these 3 forward slashes do is it tells Stata that the command continues down, and I'm doing this to separate the lines to better explain the different options. Otherwise, we can just put it into one single line, and that will be a little bit confusing. You don't need to use them. If you want to put everything in one single line, that's fine. This is just for me to better explain the options. So basically, this command continues down, and this is the next graph, also with the conditional, but instead of the US, we're going to use United Kingdom. And we can use the same options, the title, the labels, control of the labels if you want, Y title, X title, the T label that we have. And now this is a new line. Because we have 2 different countries, we need to tell Stata which countries are we talking about. So that means in the legend, we can control how the legend looks like. And then there's an option called legend. And then we mention the labels. 1 is for the United States, 2 is for the United Kingdom. If you don't know what order to put them, is in the order in which you put the graphs. So the first one is for the US, the second one is for the United Kingdom. So let's just select that and run. And here we go. So we have the 2 graphs. The red is the United Kingdom. The blue is the United States. You like this graph? Right-click, copy, and paste it in your Word document. So here you can see the trends for both countries. And one of the things that you need to start considering is the nature of your data, or the characteristics of the data when you are actually comparing things. In this case, you can see right away that the United States have far more cases than the United Kingdom. But one that could be also due to the fact that the United States have probably almost 5 times more population than the United Kingdom. So one thing that we, to check that, we can use a command called table. And this allows us to get some many statistics per category. So I'm going to do table. You can also, I forgot to mention that in there, so just to type it, just type help table if you want to know more about this command. This one is one of the commands that changed. I'm using Stata 17. I think it changed from Stata 16. You have to be careful when you find help pages with table, because after Stata 16, this command changed and changed dramatically. So table country 1 if they var only for January, the first one, January 22, and I want to know the population. I want the total population for that date per country. So this is a table that has the population per country, total population per countries. So if you look at the United States, it has 331 million people, almost 332 million people, and the United Kingdom has 67 million people. So the graph that we saw has this. One of the reasons why this is you see such discrepancy in the trends is because population problem. So we need to account for that. We need to adjust the data for population. So one way to do that is, again, the command generate. We're going to create a new variable that accounts for population, basically cases population adjusted. So this is, I'm going to call this new variable cases 100K, and that's going to be equal to the original cases variable divided by the population divided by 100,000. I'm going to do the same thing for deaths. So check, no errors. One of the things that I also advise you is every time you run a command, make sure you check that there are no errors, because I've seen cases where students come to me, they've been running the commands and somehow they get to a point where nothing works. That's because at some point when you run the command from here, they assume that the command actually works. So as you can see, sometimes work, sometimes don't work. So sorry. So make sure that you always check that the command did what it was expected. So now we're going to use the same graph, the same code. The only difference is now I'm going to use cases per 100,000, and now I'm going to add one more country to the graph so you can see how this works. Now these graphs are separated by 2 forward slashes. Now after the United Kingdom, I'm going to do another one, and before because we're adding more graphs, I'm going to have some control over the color of the graph. So for the US, I'm going to use a black color, I'm going to use red for the United Kingdom, and I'm going to use green for Brazil to separate them a little bit more clearly. The rest is basically the same. Notice that now we add level 3 in Brazil because that's the order in which we enter in the graphs. So let's select this graph on run. And now the graph looks a little different. So you can see the United States is now halfway here in terms of the cases, cumulative cases. The United Kingdom, it has far more cases now, and Brazil is interplaced in this list. Let's say the death file variable. this is what it looks like. At the end, pretty much all 3 countries are actually converging to a similar level after being, dancing around. So the data that we've been plotting so far is the cumulative cases. Now, we're interested in checking the daily counts. So basically, if the cumulative case today is 10 and the cumulative case yesterday is 7 or was 7, the daily count for today should be 3. So basically, it's today minus yesterday. Again, you can just retype the xtset to make sure that we have the panel data set. Normally, you don't have to do this, but sometimes when we change or we keep doing things that uses time series operators, Stata kind of forgets. So, and then you get the error that the data is not sorted. So if you get the error that the data is not sorted, we just rerun the xtset, and that will solve the problem. So since now we have that, we're going to create a new variable, gen, that's a command, called daily cases, equals to cases today minus cases yesterday. So you see this L1 right here? It says, graph me the case. So it's going to get country A today minus country A yesterday. And it's going to do the same thing for all the countries. So it's going to grab the previous value, and that's going to give us the daily case. I'm going to do the same thing for the population adjusted variable, and the same for that. So I'm going to just, what I'm going to do is I'm going to run these 5 lines of code with the browse. And here is another way to show you that the browse, you can also select what to see. And this is useful for example, when you have like 5,000 variables in the data, and you don't want to see 5,000, you just want to see the ones that you care about. So here in browse, you can just list the variables that you want, and then you can just check them out. So in this case, if you notice, the first case for every country should be missing, because obviously there is no January 21st for nobody in the data. And then we can go here. So let's say, for example, here, in this case. So from February 23 to February 24, we have 5 cases. So the daily cases on 24, we have 5 because we didn't have anybody before. Then after that remains with 5. So basically there were 0 cases, 0 new cases until March 11. So it went from 8 to, actually from March 7. It went from 5 to 8. There were 3 new cases, so on and so forth. And when you change countries, it cannot resets. This is the nice thing about the xtset and using the time series. You see here, as long as when it changes from Azerbaijan to Bahamas, it cannot restart. Right? So otherwise, this will be minus 800 and something. So basically, we have a missing, and it restarts every time the country or the time series starts new. Now let's get some summary statistics. The summarize command that I showed you before, you can also shorten it as a SUM. And then also you can list the variables for which you want. You can select variables for summary statistics. So here only the daily cases and the daily cases with population adjusted. And here you can start checking the data, and you notice that there are negative values in the daily counts. This could be because maybe the people adjusted the data at some point, and then okay, we made a mistake a few days ago. Let's just reduce the numbers or adjust the numbers, or they could be entry errors, right? So at this point, if you notice there are negative values, basically it couldn't be a case that they were like minus 348,000 cases one day, right? So could be an error. So at this point here is where you have to make a decision of what to do about this. For the purposes of this exercise, what I'm going to do is I'm going to convert all the negative values to zeros. So they cannot be negative daily cases. So, and I'm going to use the command replace that we used before to change the names of the countries. So I'm going to replace the daily cases variable when I make them to 0 if daily cases is less than 0, basically negative. And I'm going to do the same thing for the other variables. So I'm going to run this code, and now we know the minimum value is 0. So as you notice here, I mean, we haven't even started to do some serious data analysis. So we are doing serious data analysis. We are not doing any statistical analysis. And we are spending all the time just cleaning and making sure that the numbers and the variables are in the right format. Believe me, it's better to spend time cleaning the data than later on finding that your results don't make sense. And sometimes the results don't make sense, not because the actual data doesn't make sense. It's just because we have weird values in there, negative values, or the variables were not properly cleaned. So this is why I believe that the first components of the anatomy of data analysis, which is basically the importing, the merging, the cleaning, the preparation, all that you should spend time doing, because you don't want later on your data to give you errors or your data to give you the wrong information just because some of the values were not proper or some of the variables were not properly cleaned. So now that we have this, now let's make some graphs for the daily cases. So it's basically the same type of graph, the same options, the label, the title, the scale. And now instead of daily cases, I'm going to use daily cases. So this is how the daily cases look for the US. And the same graph, I'm going to do it for the edits. For example, there is some cycle in there. Now, if you notice during the pandemic, the news reports were always focusing not just on the daily cases, but also they were focusing on what is called the 7-day moving average. So how do we do, how would they estimate the 7-day moving average here? There are two ways. One is the manual estimation, which basically involves using the time series operators, the lags. For example, you can make one variable. I'm going to call it, in case you run this, I'm going to call it _m just as an extra. Let's say you get the 7-day moving average of deaths, and this is basically going to be equals to the current value, daily deaths, plus the previous case from yesterday's value, plus 2 days ago value, plus 3 days ago value, so on and so forth, all the way to 6. 7 is because we have the current one, and we divide it by 7. That's the moving average. So at least at the basic level. So this is the manual estimation. You will have to do this for all the 4 different variables that we have. Stata has this user written commands, which are some add-ons to Stata. These are not commands that are native to Stata, but somebody actually wrote it for Stata to give a little bit more flexibility and more functionality to the software. There is a command called egenmore. So if we type help egenmore after we install it, you're going to see some of the options. You can also see the egen command, this is Stata command, this is user written command. Now, when you have to install, and you will install a few add-ons to Stata to make it more functional, there is a command called sse install. So you install it there, and then you put the name of the add-on, And then you can also do replace in case it's already installed, it updates it. So I'm going to just select that and run. So in my case, I already installed it. It's here, but if you don't have it, it's going to tell you, okay, so I installed it, fine. Again, since we're going to be using some sort of time series, let's just rerun xtset just in case we don't. So you don't have to do this, but in case you get the non-sorted error, you have to run it. Now, the function in EGENMODE, there is a function called filter. And the command is called egen. Egen is also a Stata command, but it does different things. So egen is short for extension to generate. So basically these are it's a special command that has way more to functions to actually allow you to estimate, I don't know, group totals or group averages and all that. This is in the native one. In the new one, in this one, you can actually use this filter option to actually create moving averages. So the option here, after the comma, you can take how many lags you want from the 0 to 6. This is similar to this, right? And then you want to normalize them. That's what it takes. That's what makes the average. And I'm going to apply the same to the other commands. And I'm going to browse them. So if you notice here, for example, Azerbaijan, this value right here is the average of this 1, 2, 3, 4, 5, 6, 7. So it takes all these values and take the average. This 1.7 is basically the average of this. Now, when we change from one country to the next, notice that there is no values. So Stata doesn't do anything until it finds the 7. 1, 2, 3, 4, 5, 6, 7. Right? And then it goes all the way down. So that's the 7-day moving average. And now let's see how it looks. Same graph, same options for the United States. Now look at here. We are going to add some additional options here because we are plotting the US. We're going to add a vertical line. Again, we are using T-line here because this is a day variable. If this variable was not a day variable, we have to use X-line. So T-line, I want a vertical line on January 20, 2021, which is basically the day where the presidential inauguration for Biden. So that's going to be a vertical line. And then you can add text to your graphs. The format for the text is, the function is called ttext, and then you need to give some coordinates. So in this case, the coordinates is the y and x coordinates. So around 700,000 for 20 of July 2020 and 700,000 for 20 of July 2021, and then you put the text that you want. So I'm just going to select this and run. And that's the trends from what. So basically, what you're doing here is you are providing more information, more context to the trends that you see in the data. And then you can just start making your own inferences. Let's see how the dates look like. So this is as you update this data or you rerun this code for add more data, you can see more trends later on. And let's do the same thing, just comparing two countries. So these are the trends for the United States and United Kingdoms for the 7-day moving averages. Deaths per 100,000. One common procedure that we usually do when we deal with time series is sometimes we want to estimate the growth rate. The growth rate is, the normal growth rate is from or the arithmetic growth rate is from 1 year to the next, 1 day to the next, 1 quarter to the next. So basically, it's a percentage change. So again, the variable that we use is the command that we use is generate. So let's call it generate daily 7 cases, and I'm going to call it GR at the end for growth. I'm going to apply this only to the moving averages. And here you can use also the time series operators. Notice this is lowercase l. You can use lowercase l or uppercase l. That's fine. So daily cases minus L1 daily 7 cases divided by the previous one times 100. So that's going to tell you the percentage change. Instead of the daily change, it's going to tell you the percentage change from 1 day to the next. So I'm going to do the same thing for deaths and then check it out in the data. So you did it over there, and then here we just need to check it out here. So this is daily cases 7, this is daily cases 7 GR. So this is what we have here. So this is basically grow about 200% from here to here, 33% from 42 to 57, so on and so forth. So this is the growth rate. Now let's say for the US, we're going to use the same format with the text. This is how it looks. So if you notice, there is no lines and there is no text. Why is that? One error that we have here is Stata doesn't recognize because we forgot to add one more, the 3 forward slashes here. So when you do this, when you separate the options to have a better or a cleaner code, well, this is easier to fix in case there is an error. In this case, the error was that we missed the last 3 forward slashes, and now we have the lines. So basically, Stata stopped here. It runs only this part. So that's it. Basically, with the time series data, you can see the trends, you can see cycles, you can see patterns, and the next step is to let's check some scatter plots.